In this video, we will explore arithmetic sequences, its definition, and examples. We're going to end this discussion by talking about the partial sum of an arithmetic sequence, which is the sum of the first n terms of an arithmetic sequence. The formula is the summation of I from 1 to n of a sub I. If you are not familiar with what a summation is, please visit my video on summations just to get a little bit more information on what is actually happening. Now this simplifies to n divided by 2 times the quantity of a sub 1 plus n specifically for arithmetic sequences. Now let's look at an example of how to actually apply this. Find the sum of the first 50 terms of the arithmetic sequence S sub 50. Now here, we're only given the first 4 terms. How in the world can we find the summation of the first 50 terms if we don't even know what the actual terms are? We're going to use some of the tools that we've been learning throughout this video. So remember again, the partial sum formula is S sub n equals n divided by 2 times the quantity of a sub 1 plus a sub n. We already know what our a sub 1 is, and that's negative 17. Now we are going to have to use some of the things that we learned earlier to determine what a sub n is. Negative 17 is the first term. The second term is negative 12. Taking you back a little ways, you should remember that negative 17 is actually smaller than negative 12 because the larger the negative value, the smaller the actual number. Think of a bank account. You don't want a large negative number. So that means that for me to go from the first term to the second term, I'm actually adding because the numbers are getting larger. So let's just look at it without any negatives. 17 minus 12 would give us 5. So we have a positive 5. Negative 17 plus 5 gives us negative 12, plus 5, negative 7, plus 5, negative 2. So that means that our common difference or distance difference, it is interchangeable, is 5. Now let's look back at our general equation or general formula for this specific sequence that we can derive. So that equation was a sub n equals a sub 1 plus d times the quantity of n minus 1. Now this time we actually are looking for a number. So we're looking for a sub 50. We know a sub 1 is negative 17 plus d, which is 5, and then n is 50 minus 1. So I have negative 17 plus 5 times 49. So I have negative 17 plus 245, 5 times 49. And combining those two, I have 228 as a sub 50. Now, going back to our summation or partial sum of the arithmetic sequence, I have S sub n, which again, we're looking for S sub 50, equals n divided by 2, 50 divided by 2, times a sub 1, negative 17, plus a sub n, 228. So that's simply 50 divided by 2, 25, times 228 minus 17, 211. So 25 times 211 gives us 5,275. So the partial sum of 50 terms, of the first 50 terms of the arithmetic sequence is 5,275.